6.3 Numerical Model. What is a numerical model? According to Dexter Davison's Assessment2.com, a numerical model is a form of quantitative analysis which we can use to analyse our sports performance. It is a very factual model, which means it is objective, and it mainly focuses on the physics and motion within a performance. There is only a right or wrong way that someone can do something, which means that this model works when you are having to analyse figures and numbers. The numerical model is based on a perfect model that you can either create or find. It can be literature-based, such as normative data, athlete-based, such as elite performers, or a combination of the two approaches can be used. In this assignment, I have chosen to compare my result to a good player who is an elite player based on literature found on a trustworthy site online. I will assess the speed and linear motion of someone through a 20-metre sprint and measure power through a vertical jump. Both of these tests use similar skills to those that are needed in a basketball game. I will make a perfect model of the numerical model based on elitist or specialist scores which will be taken from literature online. Furthermore, I will also use a better player from my class group who plays basketball regularly, so that I have someone to compare results against who are a similar level to the bad player. Academic literature, which comes from online such as Google Scholar, are the most trustworthy places to source our perfect model for an elite player, because these sites have been peer-reviewed by other journalists to ensure that all data uploaded is correct and significant to the time that it was recorded. Therefore, I have chosen to use data from the NBA team, as these scores come from a credible website and fit in with what I'm trying to find with the 20-metre and the vertical jump tests. For movement to occur in a sport such as basketball, we rely on forces to allow us to create a motion. We'll be focusing on linear motion and some forces, as these allow us to create a motion. As a numerical model is a type of quantitative data analysis, it allows us to measure a performance or skill by using numbers. You can measure things such as angles and speed, and then look at literature to find out how your clients relate to a general numerical model. For example, we could film and compare the speed at which a professional player turns compared to our non-elite players. Kinematics are the type of motion that we produce. This means that it is the movement of an object or a body which occurs when a force is applied to it. Kinematics can either be linear or angular, such as our 20-metre sprint, which is one of our tests that we did in this assignment. Kinematics also relate to kinetics, which is a force. Kinetics are the forces involved to make a movement possible for the body or the object. There are two different types of kinematics. These are linear kinetics and angular kinetics. Linear kinematics are a type of force which is linked to your own mass, weight, and how much gravity you have, whereas angular kinematics are linked to your movements and how your levers such as your bones allow you to create movement. Alongside this, there are three different types of motions that can be created from the kinetics. These are known as linear motion, angular motion, and projectiles. The other type of movement is known as general motion. However, this is a combination of linear motion and angular motion. So, when stood still, you're at equilibrium. However, when movement occurs, your weight and your ground reaction force become unequal, which allows you to move, and this unbalances your equilibrium. Angular motion is a type of movement that occurs around an axis, such as when someone rotates around a bar in gymnastics. Linear motion is where you're moving along a straight line, such as when you're skydiving. And lastly, projectiles are the measure of an angle, and this is where velocity links to and affects the distance that you can move. For example, the angle of your knees bending in a long jump and the speed that you're running at will affect the distance that you are able to jump. Having this overall understanding behind the numerical model allows us to consider and explore how we can perform better in our different sports.